Here we go. Welcome to chapter 6. We're going to do sections 3 and 4 today, which is about polynomial division and synthetic division. The last time we met, we discussed rational expressions, how to simplify them, how to add them, subtract them, and multiply them a little bit. Now we're going to talk about polynomial division and synthetic division. This is a great thinking task before we actually get into it, that if you actually spend the time doing this, you can eventually model all possible solutions with a polynomial in such a way that if you were to eventually figure out a 10 by 10 by 10, you'd be able to answer the question, or an n by n by n. But again, what's going on here, and I'll leave you to do this, or to at least try this on your own, maybe when you're free time, sitting down, nothing else to do. So when I say a 3 by 3 by 3 cube, I'm talking about if you make a cube here that's 3 by 3, and then we, again, it's a full-size cube. So like a Rubik's Cube, and then here, and yes, it takes some time, but you can, that's not a very good line. You can eventually draw these in pretty well. Ooh, also, I missed that one. But what the question is asking is, if I was to take this and dip it into water, or into paint, and then pull it out, and then let the paint dry, and then peeled off every cube. So then took this cube off, this little one here. This little cube has 3 sides that are painted. If I were to look at this cube right here, think of this, and then on the bottom, those 2 sides would have 2 sides painted. And then this one right here in the middle would have 1 side painted. And if I peeled off all of the ones with paint, how many are on the inside that have 0 sides? So just if you're curious, like in this one, 3 sides covered would be all of the corner pieces. So this one here, this one, this one, this one here, that one, this one, and then the one that we can't see that's hidden in the back. So 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 of them with 3 sides painted. How many have 2 sides painted? There we'd be looking at this one, here, 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 there, and then there's some hidden on the back for how many are. So that's kind of getting at how many they're going. And then how many with 1 side, that's going to be actually pretty easy, because I'm going to have just this 1, 2, 3 that I can see, but then there's the 3 hidden sides for a total of 6. And then 0, if you peel all of them away, right? So if I take these away, basically all of these will disappear. All of those on the back will disappear. On this side, 1 on the top, that's a whole side on the back, and then 1 on the bottom will actually going to be ending up with, in this particular cube, there's just 1 cube in the middle that has no paint on it. So as for a thinking task, my challenge for you is to go through, do it then, well, I almost finished it for a 3 by 3 by 3. Figure it out then for a 4 by 4 by 4, 5 by 5 by 5, and then from that, see if you can figure out a way to kind of put all your data together and start figuring out like how you would do it for this. But right now, let's go back to when we did long division with the algorithm for long division. If I had the number 1, 2, 3, 4, 5, and I was going to divide it by 15, I would look and say, how many times does 15 go into 12? 0 times, so I have to go to the next thing over. How many times does 15 go into 123? And let's see, 30, 16, 9, maybe 7. Oop, put it above the wrong thing. We'll see if 7 works. So then what we do is we go 7 times 5 is 35. 5, carry the 3, 7 times 1 is 7, plus 3 is 10. Then I divide, or sorry, then I subtract. And I'm going to actually end up with too much, which means I can do more. So let's see if it's 8. I know some of you are saying, well, I got a calculator, I can do that, which is fine. 8 times 5 is 40. Right? 8 times 5 is 40. Carry the 4. 8 times 1 is 8. Plus 4 is 12. There we go. Now we're going to subtract, and I'll have a remainder of 3. This 4 comes down. $15 into 34 is 2. 2 times 15 is 30. I subtract 4. 5 comes down. 5 goes into 45. 3 times 5 is 15. Right. 3 times 5 is 15. Carry the 1. 3 times 1 is 3, plus 1 is 4. Subtract, my remainder is 0. So that would mean that 15 is a divisor of that number. Now again, you're saying, oh, I can do that in my calculator, but we're going to be getting to polynomials here. So let's look at the next one, and we'll 1, 2, 3, 4, 5 divided by 16 this time. So now this will be 7. 7 times 6 is 42. 4, 7 times, it's a really big 4. 4 up here. 7 times 1 is 7. 8, 9, 10, 11. Subtract. 3 minus 2 is 1. 2 minus 1 is 1. That number is less than 16, so good so far. Bring the 4 down. Right, this 4 comes down. And then it'll be 7 again, which is, we just did that, which is 112. We're going to subtract. And that will be 2. The 5 comes down. 16 goes into 25 once. 16, subtract, and that remainder is 9. So then my final answer with a remainder of 9 would be 771 and 9/16. All right, the remainder goes over the divisor. The remainder goes over the divisor, because the divisor is what's going into the dividend. All right, so now we're going to do it with this. Start with my equation. 10x cubed minus 5x squared plus 20x. And now here's where we're going to have several problems like this. Then I'm going to say plus 0. No matter what I'm going to do, I am always going to look at the highest power. And so in this case, it's ax cubed plus bx squared plus cx plus d, where the exponents are going down by 1 every time. 3, 2, 1, and then no exponents. If there's ever anything missing, you have to put in a 0 in there while we're doing our long division. And that'll be the most common mistake people make, is they will forget to have 0 in place of when there's an actual, or when there's a missing variable, so to speak. All right, so here we go. We say, how many times, 5 times what gives me 10? Well, that will be 2, and it goes above the x squared. And the reason why is I say, okay, well, x times what is x cubed? X squared times x is x cubed. So now, there's my, how many times does 5x go into 10x cubed? It goes in there 2x squared times. So we go 2x squared times 5x is 10x cubed. Going to subtract, that's 0. Bring down the next term, negative 5x squared. 5, in order to go become, or rather 5 times what is negative 5? That will be negative 1. And then x times what is x squared? That's x. And you'll also notice that x squareds are going to stay lined up in the same column. My x's will be lined up in the same column as well. So I'll have negative 1x. And here, you don't have to write the negative 1. So we could have it just as negative x. Negative x times 5x is negative 5x squared. Again, when we're dividing, we subtract. So negative 5 minus a negative. When it's minus a negative, what I'm thinking is, oh, that's plus a positive. So that adds up to 0. Bring down my next term. 20x, and it's a positive 20x. And they were saying, all right, 5 times what gives me to 20? That would be a positive 4. 4 times 5x is 20x. And as we do in division, we subtract and we get 0. Now, we could have written this 10x cubed minus 5x squared plus 20x all over. Actually, we could do it like this. Each of them divided by 5x, because it's the same as saying it's all divided by 5x, and got to the same place. But I wanted to show long division so that when we make it a little bit more complicated on the next slide, we can follow along. So now we have this going on. So now my polynomial is the highest power is 2x squared. Next highest power is x, so it's minus x. Next highest power, there is no power, so that's the minus 10. We are not missing any terms, so I do not need to put anything in there. And I'll go x plus 2. Procedure stays the same. X times what gives me 2x squared? Well, x times 2 will give me 2x. X times 2x will give me the 2x squared. And then I bring this and I multiply it down. And now instead of there just being one thing here, there's 2. So I'll go 2x times x is 2x squared. 2x times positive 2 is positive 4x. And I'm going to subtract. Be real intentional about that. 2x squared minus 2x squared is 0x squared. Negative x minus 4x. And if you need to, you can write it somewhere else as a quick reminder. So we're going to go negative x minus 4x. Well, minus is the same as plus a negative. So I'm going to have negative 5x. Bring down the next term. Negative 10. And then I say, all right, x times what is negative 5x? Well, x times negative 5 will be negative 5x. So I'm going to go negative 5 times x, negative 5x, negative 5 times 2, negative 10, subtracting. So negative 5 minus a negative is plus a positive. So negative 5 plus 5. This adds to 0. Negative 10 minus a negative 10. Again, remember it's always subtraction. Negative 10 minus a negative is plus a positive. So negative 10 plus 10 is also 0. And then I'm done. How do I know I'm done? Because I ran out of columns here. X squared, x, no x's, I'm done. So this, when divided by x plus 2, yields 2x minus 5 as my final result. Or in other words, if I have x plus 2, and I multiplied that by 2x minus 5, and it goes in there exactly because my remainder is 0. if I were to remultiply that out, it would multiply back to this, because that's what division is, right? Division and multiplication are inverse operations. Let's try this again. Slightly different looking equation. What I notice right away is as I look at this, there's an x cubed and x squared, but no x. Again, the most common mistake people are going to make in doing long division is not including all of the terms. So technically, there is an x term, it's just 0 x's. So when I go to do long division, I need to make sure I write down all the parts. 10x cubed minus 5x squared plus 0x plus 20. I'm going to divide it by x minus 5. And I'm looking to see, I need x to become 10x squared. So in order to do that, I need to multiply it by 10, and I need to multiply it by x squared. How do I know this? Well, in order to get 1 to 10, I got to multiply 1 by 10, so it's 10. And since this is only a single x, I need to be x cubed. So I'm 2 short, right? There's 3 here. There's only x to the first power here, so it's going to be x squared. And it's also, I mean, generally speaking, just like when you do regular long division of numbers, you're going to be over the top of the one that it's that same place value. So x squared times x is x cubed. So it's going to be like the one down to get you the next one up. But we do this. 10x squared times x is 10x cubed. 10x squared times negative 5 is negative 50x squared minus 10x cubed minus 10x cubed is 0. I'm not going to write the 0, but I could put it right here if I wanted to, 0. Then I have negative 5 minus negative 50. So minus a negative is plus a positive, so negative 5 plus 50 is 45x squared. Then I say, all right, bring this one down, and that will be plus 0x. I have x. I need it to be 45x squared. So up here on top, it'll be plus 45x. 45. So that gives me the 45. And then x times x will give me the x squared. So I'll multiply 45x times this whole thing. So 45 times x is 45x squared. 45 times negative 5. So that will be 225x if I did my multiplying right. So 5 times 5 is 25. 5 carry the 2. 20. Here we go. Oh, and I need to make sure I pay attention. This is a negative 5. So this has to be a negative there as well, because it's 45 times negative. Positive 45 times negative, so minus. There we go. And then we are going to subtract 45 minus 45 is 0. Again, that should always be 0. This should always be 0. This should always be 0. That's the goal of doing long division. If you don't get 0, then you did something wrong up here. 0 minus a negative 225. So minus a negative is plus a positive. So this will then be positive 225x. Bring this down. Plus 20. Up on the very top, I'm going to then say, well, this is going to be plus 225. Because when that multiplies, 225 times x will be 225x. And then 225 times negative 5, which I don't have my calculator out, so I'll do this. And it's times negative 5. So 25, 2, 10, 12, 2, carry the 1, 10, 11. There we go. Minus 1, 1, 2, 5. Minus, which means this will be 20 minus a negative, which is plus a positive. So those will add up to 1,145. And that's my remainder. What do I do with my remainder, you say? Well, this is where, like when we did the one where it was 1, 2, 3, 4, 5 divided by 16, it is the additional piece at the end, so it will be plus 1145 out of x minus 5. So when this polynomial is divided by x minus 5, this is my resulting equation. Or if I took that and multiplied it by x minus 5, it would give me this original equation back. In order to do that, I have to go x times this, x times this, x times here, and then x times here. And then I do minus 5 times that, minus 5 times that, the minus 5 times this, and then minus 5 times this. And then after all that is simplified, it would give me the original equation, the original numerator, I should say. And because there is a remainder, we would also say that x minus 5, or that this polynomial is not divisible by x minus 5, but we would also say that 5 is not a root. All right, so roots are whatever would make this 0. If I put 5 in there, 5 minus 5 is 0. So if this would divide into this, then we'd say 5 is a root. Since this does not divide into this, then 5 is not a root. All right. In other words, also, 5 is not a 0. It does not divide in evenly. Synthetic division is another method that some people think is much, much easier. And it requires just a couple things that we do differently. Division, when we do division, we're actually using subtraction. When we do synthetic division, we're doing addition. And I don't write any of the variables. So I would start with just the coefficients for each of those terms. 2, negative 1, negative 10. So I'd write 2, negative 1, negative 10. And then right here, instead of putting x plus 2, I would write what would make this 0. What would be the root that I'm looking for? The 0 would be negative 2. And then the procedure would be, once I get it written down, and we're going to be adding. The first thing we do is we bring this 2 down to right here. And then we take negative 2 times 2 and we write it here. So negative 2 times positive 2 is negative 4. And then because it's adding, I add those. So negative 1 plus negative 4 is negative 5. Then I take negative 2 times negative 5 and I write it over here. So negative 2 times negative 5 is 10. I'll write it here. It's positive 10. And I add. What that means then is my solution would be 2x minus 5. If the original equation is x squared and I do division, my result will be 1 power less. Because I'm taking x squared, I'm dividing an x out of it. So this would be the x column, this would be the coefficient column, and this would be then if there was a remainder. And my remainder is 0. And this looks just like a problem we did earlier. So again, if I were to take x plus 2 and 2x minus 5 divided here, that got my answer. So if it divides evenly, I could multiply them to get the exact same thing back again. synthetic division here. 6, 5, 4. We're missing 3. We're missing 2. We have 1. And we're missing 0 values. So when I'm doing synthetic division, just like regular polynomial long division, most common mistake people make is, that's right, they forget to include the missing terms. So for synthetic division, I will go 4, negative 25, positive 35, and that's for the 6, 5, 4. There isn't an x cubed, so there's 0 x cubes. There's not an x squared, so there are 0 x squareds. There is an x, so that's 17. And then there's no constant at the end, so that's just 0, because it would be plus 0. So again, what this would be 4x to the 6th minus 25x to the 5th plus 35x to the 4th plus 0x to the 3rd plus 0x squared, because there aren't any, plus 17x plus 0. Here, I write the root. What makes this 0? 4. If I put 4 in right there, 4 minus 4 is 0, so my root, or my 0, is 4. Procedurally, bring the first item down. And that's always the first step. 4 times 4 is 16. And I add. Negative 25 plus 16 is negative 9. And then I multiply. 4 times negative 9 is negative 36. I add, that's negative 1. 4 times negative 1 is negative 4. I add, that's negative 4. 4 times negative 4 is negative 16. And I add. Then I do 4 times negative 16 will be negative, let's see, 24 to 64. And then I add them up. And that is negative 47. And then multiplying 4 times negative 47 is, let's see, 8 carry the 2, 16, 17, 18. Negative, add those up, negative 188. Since at the end my final, if this is not 0, that means this does not divide into this evenly. But what it does leave me with is 4x to the 5th. Again, since my original highest power was 6, I'm dividing by an x. I'm now just reducing everything by 1. 6th, 5th, 4th, 3rd, squared, single x, and my remainder. So minus 9x to the 4th minus x cubed minus 4x squared minus 16x minus 47 minus 188 over x minus 4. That is whatever I was dividing into. I was dividing x minus 4 into it. So again, long division, you can get there. Synthetic division is much quicker. If you remember, we're bringing it down and over, and we're adding. And again, many people like it because adding is just something more satisfying and oftentimes easier for many people to add than to subtract with long division. So here's what I want you to do. I want you to try using synthetic division to see if you can find a solution to this. Go ahead and pause the video right now, write that down, and see if you can give it a try. Did you remember to include the zeros? Bring that one down. 1 times 1 is 1. We add is 1. 1 times 1 is 1. We add is negative 25. 1 times negative 25 is negative 25. We add is negative 25. 1 times negative 25 is negative 25. We add to 0, which means this divides into this evenly. It is what we would say is a root. This is a root of that equation. My final equation then will be x cubed plus x squared minus 25x minus 25. Write that down if you didn't get it. And again, it was just a matter of one less power. So this was power to 4. This is 1x cubed plus 1x squared minus 25x minus 25, and then plus 0 because there's no remainder. So x cubed plus x squared minus 25x minus 25. So now x cubed plus x squared minus 25x minus 25. We're going to divide this by x plus 5. And then when we're done with that, we're going to divide it by x plus 1. So if you want to use long division, you can. I would recommend using synthetic division. It will be faster. So 1, 1, negative 25, negative 25. And if I'm dividing by x plus 5, the number that goes over here is what makes that value 0, which is negative 5. So the root is x plus 5. The 0 is negative 5. Bring it down, multiply. Add, multiply. Add, multiply. Add. It's 0 again, which means x plus 5 is a root. Leaving me with the equation x squared minus 4x minus 5. 1x squared minus 4x minus 5. The reason why I didn't write this underneath is because then it says now divide it by x plus 1. So I'm going to do it again, synthetic division. And this number here is negative 1. Again, we're going to divide by x plus 1. What makes this 0? Negative 1 plus 1 is 0, so I'm going to use negative 1. And we're going to see if that works. Bring the 1 down, and we multiply. Negative 1. Add, that's negative 5, and multiply is positive 5. Negative 1 times negative 5 is positive 5, and that adds to 0. And once again, it works. The previous equation here was x squared, x, and negative 5. So then I'm going to take the power down one more. So now it will be x minus 5. Which means, ultimately, if I took x minus 5, my final answer, multiplied it by the x plus 1, which is the last thing I divided out, and then take that answer and multiply it by x plus 5, and then don't forget, from the previous page, we also had an x minus 1. That's the first thing that we divided out. If I were to go and FOIL this, and then FOIL those two, and then look at the two big quadratics, then multiply all the parts and pieces and add them together, it will give me what my original equation was on the previous slide. So you can go back and look at that if you want to check your answers and check your work. Here we go. Simplifying rational expressions, similar to what we did the other day. when I am dividing, right? This is dividing. It would be the same as if I had had this, if this was written as 5x over x plus 2 divided by 10 over x minus 2. Dividing fractions the same as multiplying by the reciprocal. So we're going to rewrite this as 5x over x plus 2 times x minus 2 over 10. Multiplication is commutative, which means it can be rewritten in any order I want. So 10 times x minus 2 in the numerator. Denominator, 10 times x plus 2. And then where can we reduce? These cannot reduce. Common mistake people make when they're reducing polynomials is trying to reduce a term instead of a factor. You can only reduce factors. So factors are things that multiply. This is a term. How do I know it's a term? Because it's connected with subtraction. Terms are added and subtracted. Added and subtracted. You cannot reduce when it's a term. This 5, however, is being multiplied. This time 10 is being multiplied, so those can reduce. Final answer, x times x minus 2 over 2 times x plus 2. And although originally we didn't define it, we could and probably should mention that for my domain, it's x cannot be negative 2. Or in other words, it's all real numbers except negative 2. Because negative 2 plus 2 is 0. 0 in the denominator results in having an undefined function. A little bit bigger. Dividing by a fraction is the same as multiplying by the reciprocal. So I will have x over y squared plus 1 over y times, we need to make that into a single fraction first. That'll be easier. I'm going to multiply this by x over x. Going to multiply it by 1, so that way it's a single fraction. And while we're at it, I might as well do the numerator. Going to multiply this little fraction by y over y. So that way these both have y squared. And so that these both have x squared as their denominators. So in the numerator, I'm now going to have x over y squared plus y over y squared, which is x plus y over y squared. In the denominator, I'm going to have y over x squared plus x over x squared, which will give me y plus x over x squared. Now I will go ahead and do the numerator, x plus y over y squared, times the reciprocal of the denominator. Reciprocal, fancy word, is for flip the fraction. Y plus x. And if it's okay with you, y plus x and x plus y are the same thing, just like 2 plus 6 and 6 plus 2 are the same thing. So I'm going to rewrite this down here as x plus y. And now when I multiply fractions, right, I do not need common denominators to multiply. I just multiply across. So this will be x squared times x plus y. Although it's not written that way, there are parentheses here. And although it's not written, there are parentheses here. y squared times x plus y. And now we're looking for things that can reduce. Since what is in the parentheses in the numerator is identical to that in the denominator, that means these are exactly the same thing. No different than when we multiplied up here to get same denominators, multiplied by just x over x. So x plus y divided by x plus y is 1. Final answer, x squared over y squared. Now I want you to try this one. So kind of going back, you can do long division or you can do synthetic division, paying attention to make sure that you if there's a possibility you're not making the most common mistake, which I've mentioned several times, and then write your final answer. This is part of what your homework is, per se, to show that you watched the video. So write that down, hit pause, write that down, and then hit play and we'll go to the next slide. So what you are going to do now that you have finished watching this video, you are going to email me as evidence of watching this video. What is, let's just say what is the most common mistake I noted that students make when doing long division of polynomials, when doing either long division or synthetic division? All right. Number 2. All right. So when you do this, complete sentence, please. Dividing a fraction is the same as, you can just finish that phrase. If given the choice, this is more about you, would you use long division or synthetic division for polynomials and why? So again, this is going to be complete sentences. As always, you are college students. Capitalizations are required. Complete sentences are required. Last thing you're going to do is the you try question that was on that previous slide. I want you to try it on your own. Yes, I'm aware that you can put it into all sorts of online math applications and see if you did it the right way. And that might be a good idea when you're done, but I would like you to try the problem, whether you get it or not, on your own. Take a picture and attach it to the email. When you take that picture and attach it, preferably you're attaching it as either a JPEG. That's going to be your most common. I do have a Macintosh Mac, so it can open up the live pictures if that's what you send it as. So, and then the due date is in Canvas, which I want to say is Friday by midnight. So class would normally have been Thursday anyways. Should not be a problem to do these 3 things. Attempt the problem, attach it to the picture. Those are the check your understanding problems that you're doing the problems, checking in the back to see if you got them right. If you are, fantastic. If not, and you're struggling to get these assignments done, reach out to me via email as well, and let's set up a time to work together so that you can be as successful as I believe you can.